It's pretty wild to think about how one tiny choice made by a single programmer can have these massive, real-world consequences. And I'm not talking about a simple typo in an email. I'm talking about choices that can literally make a rocket explode or cause total chaos for thousands of people. And it all comes down to the invisible rules that run our world. So let's pull back the curtain and see what's really going on.
Right, check this out. Back in 1996, the Ariane 5 rocket blew up just 40 seconds after launch. The cause? One bad piece of data. Or how about something more recent? In 2022, Canada's ArriveCan travel app wrongly told thousands of people they had to quarantine. It was a huge mess. And, unbelievably, both of these epic fails trace back to the most basic, fundamental parts of code.
So that's the big question, right? How can something so small go so wrong? Well, that's the mystery we're going to solve together in this explainer. And to really get to the bottom of it, we have to understand the absolute building blocks that programmers use every single day. The very first clue is figuring out how programs actually see the world.
Okay, so at the very heart of every single computer program is data. Data tells the program what to do, what to remember, what to show you on your screen. And this data really comes in two fundamental flavors, the kind that's, set in stone, and the kind that's always changing.
Just think about it this way. Some information is totally fixed, right? Like the number of days in a week. It's always 7. But other information is variable, like today's temperature. It's different all the time. Programs have to know exactly how to handle both. And the logic they follow to do that, we call that an algorithm.
And you can see that difference right here. Over on the left, algorithm A is always going to give you the number 9. No question about it. It's predictable because its data is fixed. But look at algorithm B. It's dynamic. Its result completely depends on whatever number you decide to type in. The data is variable. And that distinction, that's the first major piece of our puzzle.
So, if a program has all this data flooding in, how in the world does it keep everything organized? Well, it uses a kind of digital filing system, and in the programming world, we call these files data types. Now, choosing the wrong data type is kind of like trying to stuff a giant pizza into a tiny mail slot. It's not going to work. And this right here is a huge clue in our rocket mystery.
So this filing system has a few main folders. For example, an integer is for whole numbers. Think of the number of lives you have left in a video game. A floating point, or a float, that's for numbers with decimals, like your GPA. A string is just for text, like your username. And a Boolean? That's the simplest of all. It's just true or false, like an on-off switch. A program has to know exactly which folder to put the data in to do its job right. And here's the part that's so important to get. To a computer, the characters 573 in quotes are just text. They're no different than the words, hello world. The computer can't do math with it. But the number 573, without quotes, is a value it understands numerically. This seems like a tiny detail, I know, but mixing these two up is a classic way to create some really nasty bugs in a program.
Okay, so we know about fixed versus changing data, and we know about the different data types or folders. Now let's look at the tools programmers use to actually control them. These tools are called constants and variables, and crucially, they have to follow rules about where they're allowed to work, a concept that programmers call scope.
It's pretty straightforward. On the left, you've got constants. These are for values you absolutely never ever want to change. Think of them like the unbreakable laws of your program, a fixed tax rate, or the maximum number of times you can try to log in. And on the right, you've got variables, which are designed to be updated. Your high score in a game, for example, has to be a variable so it can keep going up.
And scope? Scope is all about boundaries. A local variable is like a specialist. It only works inside its own little department. This is way safer, generally speaking. A global variable, on the other hand, is like the CEO. It can be accessed from anywhere in the entire program. Which sounds powerful, sure, but it's also super risky, because one little change to it can cause totally unexpected side effects everywhere else.
All right, we've gathered all our clues. We've got fixed versus variable data. We have our data types, our constants, our variables, and scope. We now have everything we need to finally solve the mysteries we started with, the exploding rocket and the broken travel app.
And here it is, the culprit. The bug that destroyed that Ariane 5 rocket was something called an integer overflow. Basically, the rocket software was trying to take a big decimal number, a floating point number representing its velocity, and shove it into a tiny little box made for a much smaller whole number. The number was just way too big for the box. The
The conversion failed, the computer freaked out, and it triggered the rocket's self-destruct sequence. A billion-dollar disaster from one bad data choice.
So what about that ArriveCAN travel app? Well, while the full story is pretty complex, a very likely suspect was another data type mix-up. The app might have been misinterpreting a piece of text, a string, as a simple true or false value. In other words, the computer saw some text where it was expecting a simple yes or no, and it just defaulted to an answer that wrongly sent thousands of people quarantine orders. A simple mistake with huge real-world consequences.
So, how do the pros avoid these kinds of disasters? Well, it all comes back to the choices we've been talking about. They pick numeric types that have plenty of space to avoid an overflow. They lock down important rules as constants so they can't be accidentally changed. They keep their variables on a really short leash with local scope, and they are super careful whenever they convert data from one type to another, because they know that's where things can go horribly wrong.
When you get right down to it, it's this simple. These aren't just some obscure rules for techies. Mastering these fundamental ideas is exactly what separates buggy, unreliable software from the stable, trustworthy programs we all depend on every single day. This is the bedrock of good programming.
So here's a little thought to take with you. The next time you open up your favorite app, I want you to take a second and try to think like a programmer. Just look at the screen. What information never, ever changes? That's a constant. And what information is always updating? Well, that's a variable. The moment you start recognizing these simple choices, you're starting to see the invisible architecture that runs our entire modern world.